Hey, thanks for watching this quick video. Today, I want to take you through a scenario of a real-life e-commerce company. Let's say you have agents that help your marketing team manage ads performance. In this case, we have an e-commerce company, and we have AI agents that we have been using to generate code dynamically to help our marketing team get their answers fast. The workflow today is a person in the team asks the AI agent and saying, how is product X, for example, performing on Facebook ads campaign? What would happen is that the agent would then receive that request, would create the code to address that request, and based on the Facebook Ads API, run that code, give the data back to the user. That's great and very dynamic. The problem in this case is that every time the user asks for a similar question, the agent is regenerating the code, right? So if you have many users across your marketing team in this example making very similar requests, you have an enormous amount of tokens being spent on regenerating a very similar or the same code over and over again. The problem is that your agents don't really remember the request that came through, what the code was for, and did the code work or not, and does it need any adjustment? So today, I want to take you through an example of using SenseLab together with your AI agents to solve that problem. Problems that we're solving, as mentioned, we are solving the token wastage problem around regenerating the code every time. And you have no visibility today into which skills work or didn't work, as an example. So for example, for your Facebook ads generating the code, you've written a skill for that, pointing the APIs or whatever. In this case, you can also feed from that and adjust your skills based on the result. And the agents can coordinate or trace decisions across each other. Agents are very independent in this case, so part of the demo is to show you how your agents can talk to each other and solve that problem. All right, so this is basically connecting to SenseLab. If you have an account, you can sign up under sense-lab.ai. You can create a free account and go from there. But if we scroll down here, the scenario that we're setting up, right, seeding the data, we have 4 agents in this case. We have a Facebook ads agent, Google Ads, Redshift, and we have a dashboard agent. Dashboard agent is going to basically be pulling data from all of those. Here on the first one, we have a Facebook ads agent, right? The Facebook ads agent, let's say, based on my skill, generated this 200 lines of code to fetch campaign data. And as soon as it did, it stored the actual code in memory in SenseLab, right? Not the metadata, but actually the real code that it was generated. And it tagged as Facebook ads API within SenseLab, so other agents can easily find it. So here's the code basically generated. And one of the things that it's great is that once it generated the code, for example, ran the code, and it knows if the code actually worked or not, it goes back to SenseLab and it records an outcome. In this case, you can see that the first run, it was success, success, success. Run 4, for example, was a failure. Let's say Facebook API changed or something, but the fifth one was okay. Based on that, what's going to happen is SenseLab is going to calculate the confidence of the code generated. So when later you're going to see that when your agents look for code that already exists or pre-generated, your agents can look for a certain confidence threshold in this case. Same thing for Google Ads. I don't need to cover this. Redshift in this case generates a little bit of a different code, SQL-based, and same idea. It generates the code, records it in SenseLab memory, and also the outcome, which also has a critical failure in its history, right? And agents, as I mentioned, they can find it later. Great. So the problem is that every time the dashboard or the users would ask that for the from the agents, it would regenerate. But here is the kick, or here is the difference, right? We have all the 4 agents, the 8 blocks of code generated, and the outcome of the reports, right? So in the first act, in this case, you give your agents a way to remember things across all of them. We have a reporting agent, for example, that needs a Facebook campaign data, right? That is someone, let's say, in your team that triggered through that Facebook reporting agent. Without SenseLab, that agent or that request would come across and regenerate another 200 lines for that from scratch. With the SenseLab, it checks the memory first. So we're basically here, we do a report agent search. In this case, it looks for Facebook Ads API to understand if there is a code for that specifically, and also a minimum confidence. As I mentioned, based on the previous outcomes, SenseLab will dynamically calculate the confidence of your the outcomes generated by your agent. So you can say, I don't want anything below 0.7 or 0.9 if you want to be very strict, for example. So you make sure that this agent is going to generate code that works. And Facebook Ads API is a very generic term. For example, you can have product X on Facebook ads for this location, for example. So you can create different tags or references in this case and bucket your code by that. Your agent can also search using natural language if it needs. So for example, it's also doing another searching here. So instead of searching for that tag specifically, if you're not sure, your agent is not sure, your agent can look for Facebook campaign performance. But instead, it could look for product X campaign performance on Facebook ads. Same thing, passing the minimum confidence in this case. All right, and here, let's say we have a reporting agent, right, that used the code. Let's say that person that initiated the request went to the reporting agent found that code, used the code, and let's say it worked, right? It commits as a success in the confidence. And basically that reinforces the confidence score on that entry or the entity within SenseLab. So the confidence score of that code keeps going up. But if something happens, if anything doesn't work in this case, the confidence score is going to go down because that reporting agent can then output a failure, right? Let's say something happened or so on. And from here, your code then can be regenerated. Let's say something went wrong and you can regenerate because Facebook API changed, and you can save that as a version 2 of the memory. You can have agents auditing other agents. For example, in the scenario that you want to really make sure that no code is being generated duplicate anymore. So you can have an agent that is going to pull the memory from the other agents to understand. And if this agent sees that there is code being generated that is the same, for example, duplicate code, it can check, well, is this code being regenerated because confidence went down? So after code regeneration, confidence started to go up again, then that's okay. But if you're storing again a code that is duplicate and it's the same confidence and it keeps working, then this agent can flag and instruct to stop doing that as well. And your agents can talk to each other, your agents can check, and your agents know which one is good at what or has the memory at what, right? So now, again, your agents can coordinate. If an agent from a Facebook campaign needs data from Google Ads, as an example, an agent can talk to each other, pass requests or get requests, and use its memory, basically. Awesome. So here on the terminal, you can see that it's basically me running that code. I'm just running the demo, and you can see that I'm feeding or seeding the data in this case. Your agent is basically getting data from Facebook ads, searching from pattern tag in this case that I mentioned, Facebook ads campaign. It's fetching and it's getting confidence 0.92, for example. Another one, right, on the version 2, it's confidence 0.78 in this case, and you can see the lines. So again, instead of regenerating all of that, you're pulling that all from memory. Your agent is doing alternative search, in this case, using natural language, or used discover the agent, then read directly. So it finds the Facebook ads agent and reads from that and gets the data and writes back the outcome of that, so confidence can still be managed. Here, the agent is basically the ops agent review, doing the reviewing your other agents, in this case, that I mentioned. And define agents with failing skills. So you can use that basically, again, to feed back into your skill management. So if there are skills that are not being maintained or kept, and you want to Facebook change the API, Google Ads change the API, you can use this to basically go back and regenerate your skills or fix your skills. And the agent to agent, right? So a Facebook agent proposes a shared function to other agents, for example. Once it starts using a lot of things, the same thing, a confidence, for example, they can propose a shared function to others. You can see that my agent read the proposal and then agree and expands the proposal. And this can become a skill and so on. Awesome. So what does that look like from, you're seeing just terminal and the code. If we go basically to the screen or our dashboard, you can see some of our agents directly here. So you can see the Redshift agent, Google Ads, Facebook agent, and so on. If we click on the Facebook agent, this is as your agents wrote memory or read from it. You can see that directly here. You can see information that your agent is basically writing and talking to dashboard about topics, in this case, or entities, dashboard, Facebook ads, and share decisions, right, that we talked about. If you go to Brain Brief, you can see that this is a Facebook ads agent that specializes in developing. So basically, you can understand what this agent knows and what it does. You can see Facebook and the expertise areas, e-commerce, data extraction, Facebook ads, and so on, and cross-references, the other things that this agent is actually cooperating or sending data to. You can see hot context in this case. So we manage context and memory into hot, warm, and archival. So every time your agent is regenerating a lot of things and using the same memory, or not regenerating, sorry, is using the same memory over and over again, we rank that memory as hot, for example. So every time we pass this as a hot context to your agent, so your agent doesn't really need to read the whole thing. You're not loading the entire context back to your agent and basically using all of the context window. You first start with the hot. If it needs more, then warm, and then archival. And as your agent uses those different ones, we basically manage that. You can see the memory graph of what your agent is actually doing and generating directly here. Knowledge graph, if you want to kind of understand what's being written and so on. Another one that is pretty great, especially as you implement multiple agents to manage different campaigns. In this case, it's expertise. So we can see that this agent is an expert on Facebook ads and then share decisions and dashboards. For other agent, is going to be Google Ads as an example, or Redshift as another example. So agents can find each other based on their expertise as well and understand the data. You can see activities as well, everything that your agent wrote and so on. Everything is managed as Git. So you can see in a timeline, we call it a sacred timeline, everything that your agent did. So you can see here that it wrote all the memories, and it also created briefs, which is what we showed before, saying this agent does this, this is how it communicates, and so on. You can create a branch from this memory. You can merge that branch, much more complicated things, or advanced things, but you can see, same as Git, you can use this as a memory, agent memory. If we go back to the agent brain into overview as an example, if we go to Facebook ads, into that topic or the entity for that agent, you can see the lines of code being recorded here. In this case, it was the first one. You can see that it worked. Then it was recorded a memory quality of 1, and then confidence of 0.85.